In our earlier video on LLM workflow design patterns, we explored different design patterns that are commonly used in LLM workflows and discussed their practical use cases. One of the patterns we looked at was the evaluator optimizer loop, where we used an example of improving a documentary script step by step. In today's video, we are going to build on that knowledge. We'll take a deep dive into the LLM in a loop workflow, break down its different aspects, and finally, we'll write code to implement this workflow and see how it can be used to iteratively improve a document script. When we normally use a large language model, we ask a question or give it a prompt, and it responds with an answer. Sometimes the answer is fine, but often it may be incomplete, unclear, or even incorrect. The model doesn't try to improve its answer on its own. With LLM in loop, we don't stop at the first response. Instead, we place the LLM into a loop where the output from the first iteration becomes the input for the next iteration. The model tries to improve the answer at each iteration. Here's how it works. First, the LLM provides an initial response. Next, this response is sent for evaluation. The evaluation can be done by a human, another LLM, or through automated checks that are designed in the system. Then the LLM uses the feedback from the evaluation to refine and improve its response. This cycle repeats until we reach a final result that meets the required quality. LLM in a loop is important because sometimes LLMs give imperfect, incomplete, or confusing answers. By putting the model inside a loop, we create a process of iterative refinement to achieve desired outcomes. We give model a chance to check, improve, and refine its work. This helps the final response to be more accurate, more reliable, and more useful. LLM in loop can be implemented in different ways depending on how feedback and refinement are structured. Broadly, there are three main types of loops: human in the loop, AI in the loop, self-looping in LLM. Human in the loop is one of the most common and important ways to improve LLM responses. In this approach, a human reviewer or expert actively participates in the loop to guide and correct the LLM's output. The human doesn't just passively accept the LLM's response, they provide feedback, correct mistakes, suggest improvements, or approvals that the model can use to improve its next iteration. For example, in healthcare, a doctor might review an AI-generated medical summary to ensure accuracy and safety. In legal workflows, a lawyer could review a draft contract to make sure it complies with regulations. In education, a teacher could correct or suggest improvements in an essay generated by AI. The human feedback is sent back into the loop. The LLM then refines its output based on this feedback, producing a better version in the next iteration. This cycle repeats multiple times if needed, until the output meets the quality, accuracy, and compliance standards set by the human reviewer. In short, human in the loop bridges the gap between raw LLM output and high-quality, real-world usable results by combining the efficiency of the LLM with the judgment and expertise of humans. AI in the loop is a workflow where an automated system or another AI module evaluates the output of a generator LLM and provides feedback for improvement. Unlike human in the loop, there is no direct human involvement at every step. This makes the loop faster, scalable, and ideal for repetitive or large-scale tasks. A separate AI system reviews this output based on rule-based automated tools like grammar checks or code validators, or it can use automated scoring systems to check if output meets predefined criteria. The evaluation results are sent back to the generator LLM. The generator LLM uses this automated feedback to improve its output. This loop continues until the output meets the desired quality criteria. In short, AI in the loop allows the generator LLM to self-improve using automated feedback, creating high-quality outputs efficiently without needing humans in every step. It's ideal for tasks like code generation, content creation, or large-scale document review. Self-looping is a workflow where the generator LLM evaluates and improves its own output without requiring humans or external automated evaluators. Essentially, the model acts like its own reviewer, continuously refining its responses until they reach the desired quality. In the self-looping workflow, the generator LLM produces a first response based on the input prompt. The LLM examines its own output. This can involve comparing multiple generated responses or checking for completeness or adherence to instructions. Based on the self-evaluation, the LLM edits or rewrites the output to make it better. This cycle repeats for multiple iterations. Each loop improves the output, gradually refining it until it meets the desired quality standards. This approach is especially useful when speed, scalability, and independence are important, and the task doesn't require external domain expertise. Once we know how the loop is structured, we also need to decide how to evaluate the LLM's output. There are three main types of evaluations: rule-based evaluation, LLM-based evaluation, and real-world data evaluation. Rule-based evaluation is one of the simplest and most straightforward ways to evaluate AI outputs in an LLM loop. In this approach, we use predefined rules or metrics to automatically check whether the output meets certain requirements. Unlike human reviewers or another LLM, rule-based evaluation relies on logic and code-based checks to provide feedback. Before evaluation, we set specific rules for what points to be included in final output. For example, it can ask output in particular JSON format, or it might look for certain keywords, or it can check for content length of factual coverage. The generated response from the LLM is automatically tested against these rules. It can provide a pass or fail feedback or can give a score based on its performance metrics. The evaluation results are sent back to the generator LLM, guiding it to improve the next iteration. The loop continues until the output meets all the predefined criteria. Rule-based evaluation is a fast, consistent, and predictable way to guide LLM outputs. By applying predefined checks, we can quickly identify errors, enforce structure, and ensure the output meets required standards. It's especially useful for tasks where rules are clear and measurable, like data validation, code formatting, or specific content guidelines. LLM-based evaluation is a type of evaluation where another language model acts as a judge to assess the output of a generator LLM. Unlike rule-based evaluation, which uses predefined logic and metrics, LLM-based evaluation leverages the language understanding capabilities of LLM to provide more context-aware feedback. The generator LLM produces a draft response based on the input prompt. Another LLM evaluator model reviews the output. It can evaluate the response in several ways, like if the response meets the required quality standards or given text is clear, accurate, or relevant. The evaluation results are sent back to the generator LLM, which then refines its output based on the feedback. This process repeats for one or more loops until the output meets the desired quality threshold. LLM-based evaluation lets one language model judge and guide another, providing context-aware feedback that goes beyond simple rules. This makes it highly effective for improving outputs that require understanding of language, reasoning, or content quality. Real-world data evaluation is an approach where the performance of the generator LLM's output is measured using actual real-world feedback or outcomes. Instead of relying on rules or another LLM model to judge the output, we look at how the output performs in practical scenarios. The generator LLM produces a response or content based on a prompt. For response can be an email, a product description, a marketing message, or a chatbot response. This response is delivered to users or analyzed in the real-world environment. Data is collected to evaluate response. Data collected can be from user engagement metrics like click-through rates, time spent, or interaction frequency, or it can be user ratings or feedback surveys or other metrics. The collected data is used as feedback for the generator LLM. It can help the model adjust its outputs to improve results in subsequent iterations. The LLM uses this real-world feedback to refine its responses, repeating the loop until the outputs meet performance goals. This real-world data evaluation is especially important when the goal is not just to generate text that is correct, but to create outputs that actually achieve desired outcomes in real applications. Real-world data evaluation lets the generator LLM learn from actual outcomes. By measuring how well outputs perform in practice, the loop ensures that the AI generates content that is truly useful, effective, and aligned with real-world goals. We've covered the details of LLM in a loop and the different types of loops. Now let's build a working example. In this example, we'll implement a simple, practical LLM in a loop workflow that improves a document script through iterative refinement. We'll use the following agents in this workflow. Correction agent. This agent takes the document and applies improvements based on the given instructions. Evaluator agent. This agent reviews the corrected document, checks it against the requirements, and provides feedback. The correction agent then uses this feedback to refine the document further or move on to the next step in the process. This cycle continues until all the instructions have been addressed and we arrive at the final version. First, we created the correction instructions given as a prompt to the correction agent. Evaluator instructions for the evaluator agent. Document script that needs to be corrected, and the steps to follow for improving the document. Here we have created a LLM client script. This script makes it easy for us to connect to the Grok LLM and send prompts without rewriting the same code again and again. In this script, we have imported required libraries, loads Grok API key and the model name from the environment and created an instance for Grok client. Also, we define a simple helper function called call_LLM. It takes messages, that's our conversation or prompt history. Inside, we send a chat completion request to the Grok model. The response comes back with multiple choices, but here we just return the first message content. Now, we have correction script. We start by loading correction instructions from a text file. These instructions acts like a template or guideline for the correction agent to follow during each step of document improvement. We have the folder path, where we store all the corrected versions of the document after each step. We deleted this directory if it already exists and created it again. The correct step function runs a single correction step using the LLM. Here we customize the instructions by inserting the current step name and any evaluator feedback. We then build the conversation for the LLM. The system message provides instructions, and the user message contains the step name along with the current version of the document. This sends the messages to our Grok LLM using the helper function we created earlier. The model is expected to return JSON, but if the JSON is invalid, we ask it to retry and output only valid JSON. From the JSON, we extract three things: the corrected document, the reasoning behind the changes, and whether the step is marked as done. The function returns a dictionary containing the step name, reasoning, corrected document, and the completion flag. The process correction step function ties everything together. It runs a correction step calling the correct_step function. Then it saves the corrected document into the corrected files folder. Each step gets its own file, named by step number and step name, so we can trace the evolution of the document over time. This agent workflow handles the full correction loop for each step: load instructions, run corrections with the LLM, handle errors safely, save the corrected output step by step. Now let's break evaluation agent workflow step by step. We begin by loading a text file that contains evaluation instructions. This file contains guidelines for how the evaluation agent should check the document. Think of it as a rulebook for quality control. Evaluation step function inspects the document after a correction step. Its job is to decide if the document is good enough to move forward or if more corrections are needed. Here we customize the instructions by inserting the step name, so the instructions match the correction step being evaluated. We then create the conversation for the LLM. The system message provides evaluation instructions, while the user message includes the corrected document. The model is supposed to return JSON with fields like proceed next and issues found. If it fails to return valid JSON, we use a safe fallback. By default, we assume proceed to the next step. Finally, we log that evaluation is done and return the results for further use. Process evaluation step function is a wrapper around evaluation step function. It organizes the evaluation result into a structured format. Now this part is the heart of our LLM in a loop workflow. We start by loading the list of correction steps. Each step describes a specific improvement to apply to the document, for example, grammar correction, clarity improvement, or adjusting tone. Next, we load the raw input document. This is the starting draft that we want to improve through our correction loop. We now define document correction loop function. Result history will store all intermediate results, both corrections and evaluations. Current doc keeps track of the latest version of the document as it gets improved step by step. We go through each step one by one. At the start of each step, we initialize feedback as empty. This feedback will only be filled if the evaluation agent finds problems. Inside each step, we give the system up to 3 loops based on the feedback. Here the correction agent improves the document for the current step, using any feedback if available. The corrected version replaces the old document, and we store the result in the history. After correction, the evaluation agent inspects the updated document. It decides whether we should proceed to the next step or retry this step with more fixes. Its result is also saved to the history. If the evaluation proceeding disconnect is true, we break out of the retry loop and move to the next step. If not, we extract the issues found and feed back to the correction agent in the next retry cycle. After all steps are completed, the function returns both the full history of corrections and evaluation and the final version of the document. Finally, we run the loop on our input document. Once the process is done, we save the final corrected version inside the corrected files directory. Now we can run this agent directly in the console. The corrected documents are stored inside the corrected_files directory, which gets created automatically. In our case, we had 5 steps, and each step went through both correction and evaluation stages. If you check the logs, you'll see messages like grammar correction completed followed by evaluation for grammar correction completed. By comparing the documents across steps, you can clearly see how the script improves with every iteration, becoming more polished and refined until we reach the final version. That's it. We've successfully built an LLM in a loop workflow that iteratively improves a document step by step. We saw how the correction agent and evaluation agent work together, using feedback to refine the script until we get a corrected final version. If you try this out yourself, you'll notice how each step adds value, improving grammar, clarity, and overall quality. I hope you found this helpful and inspiring for your own projects with LLMs. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon so you won't miss our future tutorials on AI and LLM workflows. Also, leave a comment if you have any questions or ideas. We'd love to hear from you. Thanks for watching, and see you in the next video.